Okay, so in this last video, you'll see that the example is, the concept is fairly straightforward, but as I mentioned earlier, the algebra gets a little bit dicey and it involves multiple concepts. So if you haven't watched how to solve quadratic inequalities in the previous video in 4.9, I would highly recommend that you do so, otherwise you might be lost. Okay, so again, you'll see that the big picture is not that big of a deal. Okay, so they're given that the length of the longest side is the integer given. So this number is the longest side. What values of x make the given triangle? Okay, so for this first one, we're going to do an acute. Okay, so based on what we've learned so far, right, if this is the longest side, what I could write is, the sum of these two guys squared, right, is going to be greater than the longest side squared. Okay, so this is just saying c squared is less than a squared plus b squared. Okay, so this part is not that difficult, right? Because we're told that this is an acute triangle. Okay, now comes the algebra part, right? X squared plus x squared is 2x squared. And 15 squared, if you use a calculator, that's 225. Okay, now, the way, this is a quadratic inequality. Do not divide both sides by 2 and then just take the square root, okay? You'll end up with the right answer on this one, but this is not how you solve a quadratic inequality. What you need to do is move this term over, okay? And now, right, after you move it over, you set it equal to 0, and then you solve for x. Okay, so some of you might bypass this step and then, just say, oh, I'm going to divide by 2 and then take the square root. It just so happens to work out on this problem. You'll get it right, but that's not the process, and you'll get it wrong on future problems. Okay, so again, check the 4.9 video if you're not quite sure what we're doing here. Okay, so after I set it equal to 0, right, I want to solve for x, or my x-intercepts. And this one, you don't have to use the quadratic formula, right? You can use square roots. So I'm going to say, hey, x squared is equal to, move the 225 over 2. Okay, and then when you take the square root of both sides, right, you're going to get x is equal to plus or minus the square root of 225 over 2. Okay, so at this, again, this whole thing's inside the square root. At this point, if you look at your answer key, they're not going to give you the approximate answer. They're actually going to give you the exact answer. Okay, so let's practice simplifying square roots. Remember, we can split up the radical top and bottom. Okay, and the square root of 225, that happens to be a perfect square. That's just 15. Again, you're not allowed to have a radical in the denominator. Multiply top and bottom by rad 2. And your final answer for getting the x-intercepts, right, we still haven't finished this problem, is 15 root 2. Root 2 times root 2 is 2. Okay, now, if you were enter this on a calculator, right, you would get approximately 10.6, okay, plus or minus 10.6. Now, because this is a triangle, right, first thing I want to note is that the negative 10.6 is not going to make any sense, right, because it's a triangle. I can't have a negative side length. So x is approximately 10.6. Okay, now if you just wrote this answer, it's still not correct, right? This is a quadratic inequality. Okay, so let's solve by sketching. I have positive 10.6 over here, negative 10.6 over here, right? If I go back to the original problem, right, this is saying what are the x values such that f of x is greater than 0. That's what the question is asking, right? And so this parabola I know is going to go up because a is positive. Okay, so what are the x values such that f of x is positive? F of x is positive over here, right? It's positive over here. And so my solution set is x is greater than 10.6, or x is less than negative 10.6. Okay, so that's how you would solve the quadratic inequality of this problem. But again, in the context of this problem, right, it makes no sense to have a negative 10.6. So again, this 10.6 is basically just my 15 root 2 over 2. So I have the upper bound, or sorry, the lower bound, right? 10.6 is about, exact answer is 15 root 2 over 2. I want to write this because this is a problem in your practice C worksheet. And I showed you how to simplify. Okay, this is 10.6, 15 root 2 over 2. I'm not going to use this number because I can't have a negative. Okay, now that I have this, I know that x has to be greater than 15 root 2 over 2, or 10.6. I need a lower bound, right? Meaning, or sorry, I need an upper bound. X has to be less than something, right? This is already the lower bound. So, actually I could just rewrite it like this. X has to be greater than 15 root 2 over 2. Okay, so what is my upper bound restriction? Well, there's two ways of figuring that out. One is the triangle inequality theorem. Okay, so what's the triangle inequality theorem, you ask? Basically, the sum of any two sides of a triangle has to be greater than the third side, right? And so if I go back here, right, I can list out all my combinations. I can say x plus x has to be greater than 15, right? The sum of these two sides has to be bigger than this side. So x plus x is greater than 15. Another combination would be x plus 15, right, is greater than x. And of course, I could also say this x plus 15, right, is also greater than x, which, you know, ends up being the same equation. Okay, now take a look, right? If you solve this linear inequality, these x's will cancel out. 15 is greater than 0. That doesn't tell us anything. This is a true statement. These x's will cancel out, right? 15 is greater than 0. This doesn't help us. But if I solve this, right, I'm going to get 2x is greater than 15. X is greater than 7.5, right? Now, this really just gives us a lower bound. X is greater than 7.5. But remember, this number is approximately 10.6. So if it already has to be bigger than 10.6, clearly it's bigger than 7.5. So this didn't really help us. But there's one last thing you can do, right? And keep in mind that the original problem stated that the longest side is the integer given. So that means for the longest side, I'll write over here, longest side, right? That means 15 has to be bigger than x. 15 has to be bigger than this x, right? So 15 has to be bigger than x. 15 has to be bigger than x. Right? I mean, these are basically two different sides, but they're the same length. So if it's restricted by this, right? If x is the longest side, or sorry, 15 is the longest side, x has to be less than 15. And so my final answer for the upper bound is x is less than 15, but bigger than 15 root 2 over 2. Now, in the answer key, right, they kind of only wrote x is greater than 15 root 2 over 2, but they forgot to restrict it, the upper limit, which is less than 15. Okay, so the way to figure out the upper and lower limit is to use the triangle inequality and also the longest side, and also to solve the quadratic inequality. Okay, so you can see, right, this problem does take a lot of work, and there's quite a few concepts in this problem. Okay, so if you didn't quite get that, let's do another one. This time we're doing an obtuse triangle one. The big picture, again, should not be super overwhelming, right? The big picture is that, again, this integer side is the biggest, the longest side. And for me to have an obtuse triangle, right, 33 squared, right, has to be bigger than the sum of these two guys squared. Okay, so x squared plus x minus 3 squared has to be less than 33 squared, or c squared is equal to a squared, c squared is greater than a squared plus b squared. Okay, so that's the big picture. Okay. Okay, now the actual solving part is where there's lots of algebra, there's lots of simplifying, and I think this one even has the quadratic formula involved. Okay. All right, so let's solve this quadratic inequality. X squared is just x squared. Now you have to remember how to FOIL this from semester 1, right? Square the first term, this term times 2 minus 6x. Square the last term, and 33 squared is 1089. Okay, so move this term over, combine like terms. You're going to have 2x squared minus 6x positive 9 minus 1089 is less than 0, and you end up with this inequality. Okay, so again, you have a quadratic inequality. I would recommend, again, looking at 4.9's video if you're not quite sure how to solve a quadratic inequality. So notice I can actually factor out a 2 between these three terms. And if I factor out the 2 and 0 divided by 2 is just going to be 0, I'm going to end up with x squared minus 3x minus 540 is less than 0. Okay, so again, what I did was I divided everything by 2. And then if I have 2 parentheses over here, 0 divided by 2 is just 0. So I just end up with this. So I want my numbers slightly smaller. Okay, so what's the next step? The next step is to use the quadratic formula on this. And if you're not quite sure how to use the quadratic formula, I'm just going to quickly review here with you. X is equal to negative 3, right? Plus or minus the square root of negative 3 squared. Minus 4 times A times C all over 2A. Okay, so you want to plug all those numbers in. I'm just going to give you the approximate value. You can use a calculator on this one. I'm going to say x is approximately equal to negative 21.7, or x is approximately equal to 24.786. We'll just say 24 point, I'm going to round to the nearest tenth. Okay, 24.8. Okay, so after I set this equal to 0, right? This is for the solution set for it to equal 0. All right, these are my two x-intercepts. And going back to this expression right here, actually, I'm going to go to this expression, this one, the simplified one, the one where there's not a 2, and it doesn't really matter. This is saying, what are the x values such that f of x is less than 0? Okay, so like I said, the quickest way to solve a quadratic inequality is by sketching. So if I sketch it, right, here's negative 21.7, here's positive 24.8. Here's my parabola. Open circle, right, because it's there's no equal sign here. What are the x values such that f of x is less than 0? F of x is less than 0 in this region, right? The y value is less than 0 from here to here. So what are the x values? X is between 24.8 and negative 21.7. Okay, so this answer right here, what I wrote over here, solves this quadratic inequality. Okay, so that's the algebra part, right? Now, I'm not going to use the negative 21.7 because I can't have a negative side length, right? These are side lengths. I can't have negative side lengths. So I'm only going to take this portion of the solution. And actually, this time I have the positive or the upper limit of the solution. Okay, so I'm going to have a question mark over here. I might have a lower bound. And the way to figure out the lower bound, right, just like the previous problem, is use the triangle inequality to see if that helps. It might not necessarily help, right? These two didn't really help you. And use the longest side. So let's try the triangle inequality, which says that the sum of any two sides, right, is bigger than the third side. So my first equation would be x plus x minus 3 is bigger than 33. My second equation could be x minus 3 plus 33 is greater than x. And another combination would be x plus 33 is greater than x minus 3, right? So notice inequalities 2 and 3, right, are just going to cancel out, right? You're going to have 33 is bigger than negative 3, which is true, but that doesn't really help you. These x's will cancel out. 30 is bigger than 0, which is also true. That doesn't help you, right? So these two didn't really help you in finding a lower limit. But now if you solve this, right, you're going to get 2x is greater than 36. You're going to have x, if you divide both sides by 2, x is bigger than 18. You will have a lower limit, right? X has to be bigger than 18. Now let's do one more check right here. Let's do the longest side. inequality. The longest side inequality basically states that since this is the longest side, right, 33 has to be bigger than x, 33 also has to be bigger than x minus 3, okay? So if 33 is bigger than x, I know I'm limited by 33, right? But I'm also limited by 24.8. I can't go past 24.8. So this is really extraneous, right? If it's less than 24.8, clearly it's less than 33, right? So that didn't really help. But I will also say that 33 is bigger than x minus 3. And over here, right, if you add 3 to both sides, x is less than 36. Again, that does not help us, right? X is already less than 24.8. If it's less than 36, if it's less than 24.8, it's already less than 36. So the long side didn't really help us this time, but in the triangle inequality, we're given that x has to be bigger than 18. So this would be my final answer. Okay, so x is less than 24.8, but x is bigger than 18.